Hey everybody, Diagnostic Derek. It's been a while since I've made a video. Shop's been busy. It's been just ruthlessly hot out here this summer, but got to get back at it, get some more videos posted. So today I got a 2009 Lincoln MKX. Customer complains that the engine is overheating. Coolant level looks okay. I went ahead and pulled the codes, and what we've got is a P0480 cooling fan control circuit. You look at that. So these Ford cooling fans are pretty common failure. They go bad all the time. So figured I'd go ahead and show everybody how I test one of those. So we'll go out under the hood and we'll take a look at it. Okay, I removed the air filter housing, and I've got the camera sitting where the air filter housing usually is. Go ahead and adjust the angle here. This is the fan control module, which is mounted to the fan. When you buy one of these fan assemblies, it comes with motor, blades, control module and all, and it's generally this control module that is the problem. So what we're going to do is we're going to take a look at the circuit and make sure that we're getting all the signals we need for this fan assembly to operate. You'll see here on this connector that there are two big large gauge wires and there's one small gauge wire, and what we're going to do is back probe the two large wires are the power and ground for the fan. The small wire is the control signal from the PCM. We don't need to pull up a wiring diagram because I'm already familiar with how this works. So what I'm going to do is back probe the power and ground wires, and I don't know which one's which. The black is probably ground, but it doesn't matter. We're going to back probe them both, connect to our meter, command the fan on 100% with the scan tool, and make sure that we're seeing battery voltage on one side, ground on the other. So if we back probe both wires, hook both wires to our meter, when we command this to 100%, we want to see basically battery voltage displayed on the meter. Then what we'll do is we'll move our positive lead to the signal wire. We'll hook that to a lab scope, and we will look for a 12-volt duty cycled square wave that changes as we turn the fan command up and down with the scan tool. So that's what we're going to do. Okay, so I'm just going to take a couple of test leads with back probes here, and I think the purple wire, this big purple wire, is going to be our power more than likely. So we'll back probe that with our red lead, back probe the ground with the blue lead, and now I'll move the camera up so you guys can see the meter for this test. Okay, so it turns out that my snap-on scanner apparently does not have a bidirectional control option for the fan on this particular vehicle. So I've had to switch over and connect the our Ford IDS tool. We do have the Ford IDS tool here. For quick testing like this, I usually use the snap-on scanner just because it's faster to boot up, faster to get connected. But sometimes you got to go with the factory tool, so that's what we're doing here. Right now I've got the fan commanded on with the IDS tool, I think. Let me check. Okay, now I have the fan commanded on with the IDS tool. We can see with our back probes on the power and ground wires that we've got good battery voltage. I know we got some screen glare here, sorry about that. So our power and ground to the fan are good. So now all I'm going to do is move the positive test probe over to the signal wire. I'm going to back out of this, and we'll head down to our lab scope. See if I can. Sometimes this wire is kind of tough to get a good connection on. There we go. Well, had it for a second. When you're back probing circuits to do testing, make sure that you've got a good connection before you condemn a circuit, because it can be tough to make a good connection. And if you feel like you're not getting a good connection, you might have to go with a wire piercing probe, which may be what we have to do here, because I can't seem to get a good connection. Yeah. Well, I apologize for the awkward video editing. I had some problems getting a connection on this signal wire with my back probe. So I had to switch over to a piercing probe, and then the air compressor right outside the door we're working at kicked on, so I just had to shut the video off and wait a minute. But this is basically what we're looking for on this signal wire, is just good 12-volt square waves. I've got the fan commanded on with the IDS tool, and we're seeing good 12-volt square waves. You'll also notice that you don't hear the fan running, so that's obviously we've got a fan problem. If we've got good power, good ground, and good 12-volt square waves on the signal wire, and the fan's not running, then we have a problem with the fan. We could switch over and check the 2 wires that run from the module to the fan motor itself, but we always replace these fans as an assembly with the module motor and everything, so really no point in doing that. We're done here. One thing I do want to mention that's important: when you're checking the 12-volt square waves on this signal wire, you need to do that with the fan plugged in. The 12 volts is supplied to the circuit by the fan module, and the PCM pulls that 12 volts to ground as the command signal to tell the module to turn the fan circuit off and on. And it will vary these pulse widths, the duty cycle, the amount of on time versus off time, in order to control the speed of the cooling fan. So I'm going to go ahead and put the tools away, put this air filter box back on for now, and then we'll pick this video back up after that. I got the car all put back together so we can back it out and park it. We'll go ahead and let the service writer know that we're going to need a fan assembly for this. These fans are pretty straightforward. He said you got 3 wires: power, ground, and signal. The 2 big wires are always power and ground. The small wire is always the signal, PCM speed control. So really, all you got to do is make sure you got power, make sure you got ground, make sure you've got 12-volt square waves on the speed control wire, and you're done. If the fan's not running, and you know it's a bad fan, whether the problem is in the fan module, which in my experience is what it usually is, or whether it's in the motor, for us is irrelevant. You know, we buy these fans as an assembly. It's going to come with motor, blades, shroud, module, and everything. So no reason to spend any more time trying to determine if it's the motor, if it's the module. We'll just go ahead and, you know, get this customer a quote for what it's going to take to fix it and get a new fan put on it. So hopefully they'll approve these repairs, and once we get the new fan on, verify that it's working, we'll wrap this video up and call this one done. We've got the new fan installed, cleared the codes, test drove it. It's not overheating, fans are working, so I think we're going to go ahead and call this one fixed. Final thoughts on it: just you know, whenever you've got an overheating complaint, obviously you always want to check and make sure your fans are working, whether that's by turning the AC on. You know, the fans should run anytime the compressor is engaged, or commanding the fan onto the scan tool, or just warming it up to temp, watching your fan pid on the scan tool, and when the fan is commanded on, you know, check and make sure that it's running. These 3-wire controlled Ford fans, the 2 big wires being power and ground, the small wire being the duty cycle control from the PCM. Pretty straightforward testing, and you can use that same testing principle for, you know, a lot of 3-wire duty cycle controlled, you know, solenoids and fan motors and all kinds of different stuff. So a basic understanding of how that circuit works can really go a long way in your diagnostics. So I guess that's about it for this video. We'll call it fixed. We'll give this one back to the customer, and we'll see it again the next time it breaks.